Hey everybody, we're talking through confidence intervals. We kind of played around with the idea yesterday. We're going to make it a little bit more real today. So I'm going to go walk you through your first page, mostly on computer, and then we'll summarize it at the end, and then we'll go from there. So let's get going. All right, so this applet is a little different than the one that you have. What we're doing here is we're going to take 100 samples of a 50%, or what's assumed to be 50%. We're going to try to come up with what percentage of the confidence intervals that we have actually cover or contain that 50%. So I'm going to take 100 of them, and we're doing a confidence level of 80%. So we take 100, there they all go. The green ones are the ones that were successful. They're the ones that have 50% inside of it. So for example, this 83rd one has it. We had 48 out of 100 of the sample was positive. So we have a sample proportion, p hat of 0.48. We went 40% above that and 40% below that. And so we came up with an interval from 0.416 to 0.544. 50% is contained in that, so that one's good. That's in contrast to, let's say, up here, 80s in red. We had a count of 57 that were successful, so that gives us a proportion, a p hat value of 0.57, the sample proportion. And notice here, the lower limit, if you can read that, is 0.507. And then the upper limit is 0.633. So that one doesn't get it. So again, any of these red ones are the ones that don't work. And in fact, you can even sort them if you wanted to. So notice down here in the bottom, those are the confidence intervals that were too small to contain 50%. And the ones on the top are too big to contain 50%. Now here's the interesting thing here. If I look, it says containing P, so what proportion, I'm going to zoom in just a touch, I think. So notice here, out of 100 intervals, 86 of them caught the actual proportion correctly. Now, as we know, the more samples you take, the more accurate you get. So we're going to continue to do this. I'm going to add a couple thousand in. So if I add an additional 1,000, now my proportion contained on the bottom is very close to 80%. And the more that I add, it's going to bounce around, but you stay very, very close to that 80%. Okay, and that's what that first part of this is kind of go through and do. Okay, so what ends up happening here is, so down over here, so what ends up happening there, if we take many, 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 many samples, about 80% of those will capture the true proportion. Just a couple of samples isn't good enough. You need to do it a lot. So when you say you're 80% confident, if you have an 80% confidence interval, that means if you did the same procedure over and over and over again, 80% of those intervals are going to capture the true proportion. Not that there's an 80% chance that it captures it. It's saying that 80% of the time you will capture it from there. Now, let's go down here, and it says we're not going to go through and reset, but what happens when we come back and we change this confidence level to 95%? If I hit enter, what just happened to all those intervals? Now, if you didn't see it, go back and watch it again. Or if I'm really good with my editing and I have time, I'll do it again. Really slow. But all these intervals got wider. Why? Because we want to be able to capture in the long run approximately 95% of these intervals. We want to have captured the true proportion. And the only way to do that is to get a bigger net. And so that's why all of these came back. Now you can see we're a little bit under here, but that's what's going to happen there. So coming back to our notes, what happens to the intervals when the confidence is increased? intervals get bigger. Why? It increases our chances of capturing the interval. So now here is what's going to happen when we change sample sizes. I'm not sure how well this is going to work. We will. Now, instead of taking 100 at a time, what happens when check that out. It's even wider than we thought. Now we're still capturing 95%. That's beautiful. But remember how small those were before? If you're not sure about that, check this out. Actually, I could have done that before. Okay. If I change it to 250, and we do 100 intervals, look how much smaller that is. Why would that be? What gets smaller as we increase our sample size? That's right, standard deviation. So that means that whenever we're dealing here with our confidence interval, standard deviation is going to have a play in it. Okay? So I'm going to wrap this up. Oh, let's come back over here. So confidence interval, what happens? Okay. Reduce the sample size, we get larger intervals. If we do the sample size there, we get smaller intervals. Why? Because as n goes up, my standard deviation goes down. The bigger the sample, the better and tighter your data is going to be. So with that, make sure you click on the next one. We'll summarize everything up, and then you will be ready to go for the day. See you soon.